So here's our first example. 2 cosine of 2 theta minus 1 equals 0. Here's one of our new identities for today. It's cosine of 2 theta. What is cosine of 2 theta the same as? Cosine squared minus sine squared. That's what we're going to substitute in. Do you need to memorize these? There we go. Welcome to 8th period. We've been in... Okay. Hello. Here we go. We do not need to memorize these. Don't freak out about that. This is all yet. Sine squared plus cosine squared equals 1. And the unit circle. That's it. Right? Okay. That's enough. Yeah? Okay. So the whole rest of this problem is going to be the same. We're going to swap in, I'll color code the right way, cosine squared minus sine squared. Those are the same. And now we're going to treat this like we would have treated a problem that we had last week. So just like when we learned how to use sine squared plus cosine squared equals 1, and like that was like the one new thing in our problem solving flow, this is the new thing in our problem solving flow. Now it's just like a problem from last week. So you see a 2 out front of parentheses, you want to distribute, and distributing here is legal. So 2 cosine squared minus 2 sine squared minus 1 equals 0. Right, we can distribute, like 2 you can distribute. So think about what you're distributing. Is it legal to distribute that? Can you distribute a 2? Absolutely. Can you distribute a cosine? No, because cosine is the operator. Just like if you had divide by or something, you can't distribute. You know what I mean? Okay. All right, sines or cosines? Which one do you like better? Because we don't have any singlets. Okay, so we don't have any singlets in this problem, right? We said last week, singlet stays, substitute in for the squared. Well, everything's squared, so you can pick. So if you want to keep cosines, that's great. We're going to substitute in for our sine squared then. I think that is what we did 3rd period too. So what's sine squared the same as? Well, we know sine squared plus cosine squared is 1. So how would I get sine squared by itself? So sine squared is the same as 1 minus cosine squared. So anywhere I have a sine squared, I can put in a 1 minus cosine squared. And we're going to put that in parentheses. Everything else stays the same. You do get into trouble. It's easy to get into trouble with these if you do too much in one step. Same will go for proofs when we get to those next week. Spend the pencil lead to be precise, to not frustrate yourself. So we're substituting in 1 minus cosine squared. And now we're just going to solve for cosine. So it is legal to distribute a -2. Absolutely. That's a great thing to do next. That's really the only thing to do next. So 2 times 1, -2 times 1 is -2. -2 times negative cosine squared is positive 2 cosine squared. Minus 1 equals 0. Combine your like terms. We have 2 cosine squared. So I have 2 of them here and 2 of them here. So that's 4. Yep. -2 minus 1 is -3. get our cosine squared all by itself, so we're going to add 3 and divide by 4. So I have cosine squared equals 3/4. How do I get rid of the squared? Square root. And when I square root, what do I have to remember? Plus or minus. And there's something else I would do if you're square rooting a fraction, which when you're working with the unit circle, it's kind of more probable than not that you'll be taking the square root of the fraction. Do the top and the bottom. Because if you take the square root of just 3/4, it's more likely that you'll be like, oh, square root of 3 over 4, that's not on my unit circle. I'm mad at everybody, especially Mrs. Lexic. Because you'll forget that it really does, that big square root really goes over everything. And here, now square root of 4 is 2, and this is nicely, beautifully on our unit circle. And it's all of our sixths. Tiny bit. I know. It's like I'm everywhere. I am everywhere. Uh-huh. No. No, you guys all just caught super hearing from me. So when we're doing our solutions for this, we can do plus pi k 2 places instead of plus 2 pi k all 4. Which one of these are pi apart? Which ones can we group together? Yeah, these two and those two. Awesome. And you can draw your diagram. So pi over 6 plus pi k takes care of pi over 6 and 7 pi over 6 and 5 pi over 6 plus pi k takes care of 5 pi over 6 and 11 pi over 6. Mr. Schaefer does this every day for BC for like 2 students that like it didn't fit their schedule to take BC, and they like talk about all the food that they're eating and talk about all and just like make fun of the students that aren't in the class but are taking the class and watching the video. Yeah, Mr. Schaefer has 2 students that are taking Calc BC but aren't actually in the period, like are taking it later in the day. And so he does videos every day. He does lecture. Yeah, they do it. That's like independent study. We don't need to do 2 pi k for this one because for pi over 6 plus pi k takes care of pi over 6 and the one that's pi away from it, which is 7 pi over 6. And then same thing for 5 pi over 6 plus pi k. It just condenses your solution because it takes care of that and 11 pi over 6. If you were, like, let's say you just had solutions here and here, like pi over 6 and 5 pi over 6. If those are your only 2 solutions, they don't make a straight line, so they are not pi apart. So you would just do pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k, go. You have to worry about it if they are across the unit circle from each other. And so that's why we draw that little picture. Yep, absolutely. All right, this one's much quicker than the last problem. Much quicker. So what's sine of 2t the same as? Yep, and we'll use t's since our problem is in t's. So sine of 2t is the same as 2 sine of t cosine of t. It is very tempting in this problem to divide everything by cosine. And if you do that, you will lose a solution. So don't do that. If you're feeling like you should divide, stop yourself, bring everything onto the same side of the equal sign, and factor. So all we've done so far is take sine of 2t and use the identity sine of 2 theta, no matter what that, or x, is the same as 2 sine cosine. So we're just making that swap. That's all we've done so far. Okay so far? Now we're going to bring the cosine over. I like everything on the left side. It makes me feel safe and warm. I don't like everything on the right side. So 2 sine cosine minus cosine. So if you were thinking divide, you have to stop yourself and think factor instead. And when we're factoring out a GCF, just not to make you feel like you're back in Algebra 1, but when you're factoring out a GCF, you have to have the same number of terms in your parenthesis that you started with. So if you started with 2 terms separated by a subtraction sign, in your parentheses when you factor, if you're just factoring out a GCF, you need 2 terms in the parentheses separated by a subtraction sign. It's really easy with all of this stuff going on to lose things like that are seemingly little but totally mess up your solution. So what do these 2 terms have in common? Cosine of t. So that's what you're going to factor out. So what's left in our first term is 2 sine of t. And our second term, what's left is 1. And it's that 1 that I'm concerned about you missing. It's that 1 that I've seen students kind of leave behind. And now that you're factored, you could set each piece equal to 0 and solve. So cosine of t equals 0. And 2 sine of t minus 1 equals 0. That means that sine of t equals 1/2. So where's cosine 0? Yeah. Pi over 2 and 3 pi over 2. Are those pi apart? Yep. So we can just say pi over 2 plus pi k. And if it helps you to draw that diagram and to say, okay, pi over 2, 3 pi over 2, those make a straight line, so plus pi k. And then where's sine 1/2? Pi over 6 and 5 pi over 6. Again, if you need the diagram to help you, do a little unit circle sketch for yourself. Those don't make a straight line, so we're going to do plus 2 pi k for both. How we doing? The double angle identities are the easier identities to kind of just plop into your equation. Sum and difference are a little bit more challenging, but I think like once you get into the problem, it kind of flows a little easier. We're going to skip the tangent problem. We'll do tangent in a minute.